Before we get started with 4.2, are there any questions on the homework? Questions on the homework assignments? So 4.2, we're still talking about polynomial functions, but today we're going to be talking about doing operations, specifically addition, subtraction, multiplication, and division. Now there's two ways we can add or subtract polynomial functions, and that is vertically or horizontally, up and down or left and right. So if we're going to add vertically, so we're going to add 3x cubed plus 2x squared minus x plus minus 7. And we put whichever one is first on top. So we'd have 3x cubed plus 2x squared minus x minus 7. And when we list it out, if there's any missing, we need to put a space or kind of put it in a 0. So we kind of have a placeholder, a marker for that there. Now, here we have x cubed is our biggest term. X squared, x, constant term. All the terms are there. So we're good there. We'll put the second one underneath it. So we have our x cubed term under the x cubed. Our negative 10x squared under our x squared. We don't have an x term, so we don't have to put anything there. If we wanted to, we could put 0x, because 0x or no term there are the same thing, just so we have something there. And we're going to be adding. When I do this vertically, I always put the sign of what we're doing, either addition or subtraction, between each one, just as a reminder to myself which operation we're applying to all three, or here, all four terms. Questions on this so far? And now we're just going to add. 3x cubed plus x cubed is 4x cubed. 2x squared plus negative 10x squared, 2x squared minus 10x squared. 2 minus 10 would be negative 8x squared. Negative x plus 0x, negative x. Negative 7 plus 8, plus 1. That's it. Questions on how we did this here? We're ready for the next one. All right. We good? Okay, that's fine. Okay. Next one we're going to do is horizontally. So we've seen one vertically, we're going to do one horizontally. So horizontally just means that we rewrite it. 9y cubed plus 3y squared minus 2y plus 1 plus negative 5y squared plus y minus 4. We're going to write it horizontally. In standard form, yes. So the question is, does it have to be in standard form? Yes. We want to try to keep all these in standard form, so from biggest power to smallest. Now, the first thing we can do is deal with our parentheses. Since there's nothing in front of the first set and we're adding, we can really drop the parentheses. 9y cubed plus 3y squared minus 2y plus 1 minus 5y squared plus y minus 4. Because we're technically distributing positive 1 through the second set of parentheses, but multiplying by 1 does not change the number, and the fact that it's positive doesn't change the sign. So we still have negative 5y squared, positive y, and negative 4. Now at this point here, we're going to combine like terms. So we can start with 9y cubed. Is there any other y cubed terms? No, so it's just going to stay 9y cubed. Almost. I think you gave me the answer. 3y squared negative 5y squared, which would give us negative 2y squared. Negative 2y squared instead of 5. Yeah, no, you gave me the answer. The number of times I've done that, I can't count. Negative 2y and y would be negative y, because negative 2 plus 1 is going to be negative 1. And lastly, negative 1, or positive 1 and negative 4 is negative 3. Questions on how we did this here? Questions on horizontal or vertical addition? If there's one of those that you like better, if you like adding them horizontally more than vertically or vertically more than horizontally, pick whichever one you like better. I'm not going to force you to do one over the other. But I did want to show you how to do it in both ways. Questions on how to add polynomial functions? Do we feel comfortable adding horizontally and vertically? We need to see another example of adding. Okay. Now we're going to subtract. We're going to subtract vertically first. So when we subtract vertically, we pick whichever one they told us is first. So here 2x cubed plus 6x squared minus x plus 1. And again, if there's a gap, if they didn't have the x squared term, we'll leave a space. If it doesn't have the x term, we leave a space. Because again, the reason we're leaving spaces is so that our like terms line up, so we're not having this misalignment occurring. On bottom, we'll have the second one, our 8x cubed minus 3x squared minus 2x plus 9. And this time we're going to subtract. We're going to have to subtract each term. 2x cubed minus 8x cubed. Negative 6x cubed, because we're doing 2 minus 8, which would be negative 6. Next one is going to be 6x squared minus negative 3x squared. Well, the negative would make a plus. So 6x squared plus 3x squared is plus 9x squared. Our next one is negative x minus negative 2x. Negative and negative make a plus. Negative x plus 2x is plus x. Negative 1 plus 2, 2 minus 1. And lastly, 1 minus 9, negative 8. Now, unfortunately, with these addition, subtraction, and even multiplication, we can't plug the whole thing in the calculator, but we can plug the coefficients in. Because we can do 2 minus 8. It will tell us it's negative 6. We have x cubed. We can do 6 minus negative 3 in the calculator, which will indeed tell us it's positive 9. We just have to put the x squared back. Negative 1 minus negative 2 will tell us it's positive x, or 1, or positive 1x. We just have to put the variables back. Questions on this here? Are you ready for the next one? Now, subtracting horizontally, we have to be a little careful. So we start off the same as we did with addition for horizontal. We have our two terms, our sets of parentheses. First set of parentheses, just like before, we drop them because there's nothing in front of it. However, the second set of parentheses, we do have to distribute that negative through. We have to apply it to each term, which is going to take our positive 2z squared and make it negative 2z squared. Our positive 3z.
Taylor Tyson, please come to the office. Taylor Tyson, please come to the office.
Is going to make it negative 3z. At this point, we can put parts of it in. So the parts that we can put in, so we could say, because 3z and negative 2z are like terms, so we'd have 3 minus 2, which would give us 1. So it'd just be 1z squared, or we can say z squared. Our next set of like terms, z and negative 3z. So we could say 1 minus 3, which is negative 2, and we'd put our z back. And lastly, we have negative 4, and since it's the only like term, or negative 4 plus 0, we just get negative 4. That's it. So we can do the coefficients, the numbers in front of the variables of our like terms in the calculator. We just can't plug z or a variable into the 30xs or the 84 plus. Because even though we can type a variable in, it needs a value for it. So it's going to assume whatever the last value was, which if someone hasn't put a number in would be 0, which doesn't help us, or whatever number it is. Coefficients, yes. Variables, no. The only ones I know, the 89s can do that, can add or subtract these expressions, but they're banned on most all standardized tests. I think I don't know about the Inspire. I'm gonna have to look and see if it does. But again, we don't have those. They're nice for the most part, unless you're going into engineering or higher. You're not gonna need an 89 or an Inspire. You'll use it for this year and then that's it. And I think they started about 110 for one of them, so they're expensive. How do we feel about subtraction? Yeah, it's about the same as addition, but we need to make sure that that negative is applied properly. That's the only thing. We need to see another example of subtracting. We feel good with this here. If we feel good with addition and subtraction, we'll move on to multiplication. So, we're going to multiply these two together. So we're multiplying negative x squared plus 2x plus 4 and x minus 3. So we put each expression in parentheses and we'll stick them next to each other. Because it's understood for us that when we have two sets of parentheses right next to each other that we're multiplying. And now we distribute, we multiply through. So the first thing we can do is multiply through with the x squared. Well, x squared times negative x, or sorry, negative x squared times x is going to be negative x to the third. Because when we multiply like bases, we add the exponents. So 2 and 1 gives us 3. Negative x squared times negative 3. Negative times a negative is a positive. 3 times x squared is, well, 3x squared. Questions on this so far? All right, now we're going to repeat the process with 2x. Positive 2x times positive x is plus 2x squared. 2x times negative 3, 2 times negative 3 is negative 6. And we still have our x. And lastly, we multiply through by 4. 4 times x is going to be positive 4x. And 4 times negative 3 is negative 12. Now we combine like terms, yes. And the nice thing with how this ended up working out, well, like terms are right next to each other. So we still have the negative x cubed because there are no like terms with it. 3x squared plus 2x squared would be plus 5x squared. Negative 6x plus 4x is going to be negative 2x minus 12. Questions on this here? We feel pretty comfortable with multiplying. Yes. Now, technically there is horizontal and vertical. This is technically horizontal. Now there is vertical. I'm going to show you vertical for this one here. But for the rest of this here and all of what we're going to do, I'm going to mainly stick with horizontal. You can write this down if you want. You don't have to. Because with horizontal multiplication, we always start with the constant term. So we're going to do 3 times 4, which is negative 12. Then we're going to go 3 times 2x, which is negative 6x. And 3 times negative x squared, it's going to be 3x squared. So it's like when we multiplied numbers vertically before. But now we have variables. Then we'd move over one. Well, just like with vertical multiplication with 2 or 3 digit numbers, we put a 0 in the first spot because we moved over 1. X times 4 is going to be positive 4x. X times 2x is going to be positive 2x squared. And x times negative x squared is negative x cubed. And at this point here, we're going to add. Negative 12 plus 0 is, well, negative 12. Negative 6x plus 4x is negative 2x. 3x squared plus 2x squared is 5x squared. And since we don't have anything with our x cubed, we get negative x cubed. I don't know about y'all, I would prefer just doing this horizontally over vertically. Just not bad, it's just trying to make sure we keep everything lined up and in a nice order. All right. Let's look at this next one here. We have y plus 5 times 3y squared minus 2y plus 2. We'll rewrite them with our parentheses around each expression, and we're going to multiply them together. And the first thing we're going to do is distribute the y. Y times 3y squared would be 3y cubed. Y times negative 2y is going to be negative 2y squared. And y times 2 is going to be plus 2y. Then we'll do the same thing with our 5. 5 times 3y squared is going to be plus 15y squared. 5 times negative 2y is going to be negative 10y. And lastly, 5 times 2 is going to be plus 10. Now at this point here, we can combine like terms. So we'll start out with our variable with the biggest exponent, which is our y cubed. Well, 3y cubed does not have any like terms, so it just stays 3y cubed. Our next one is our y squared. Well, negative 2y squared plus 15y squared is going to be plus 13y squared. Then we have our y terms, negative 2y minus 10y is going to be negative 8y. And lastly, our constant term of 10 or plus 10 doesn't have any like terms, telling us that the product of these two expressions is 3y cubed plus 13y squared minus 8y plus 10. Questions on this here? How do we feel about multiplication? Do we feel good with this here? All right. If we feel good with multiplying those two expressions, let's look at this here. We want to multiply x minus 1, x plus 4, and x plus 5. So the first thing we have to do, even though there's more than two of them, is we're going to write them next to each other in parentheses. We're going to write each expression inside a set of parentheses right next to each other being multiplied together. Now the order in which we multiply these really doesn't matter. We can do x minus 1 times x plus 4 first. We can do x plus 4 times x plus 5 first. Or we can even do x minus 1 times x plus 5 first. I wouldn't do the last one because they're a little away from each other. But either one works. Is we're going to multiply two of these out first. So for us here, we can do x minus 1 and x plus 4 first. Well, here our x times x is going to be x squared. X times 4 is going to be plus 4x. Negative 1 times x is going to be negative x. And lastly, negative 1 times 4 is negative 4. And that there is going to end up being multiplied by x plus 5. Now, before we do any multiplication, it will be helpful to combine like terms. Our 4x minus x is going to be plus 3x minus 4. And we'll multiply that by x plus 5. Now, not combining it first is not going to hurt anything. You will still get the same answer. But instead of multiplying the x plus 5 by 3 terms, you're going to multiply it by 4. You'll have more like terms. But after we combine it, we're going to do the exact same thing again. We're just going to distribute through. So we're going to say x squared times x is x cubed. X squared times 5 is going to be plus 5x squared. Then we'll do the same thing with 3x. 3x times x is going to be plus 3x squared. 3x times 5, 3 times 5 is going to be 15. And we still have our x. And lastly, we're going to distribute the negative 4. Negative 4 times x is negative 4x. Negative 4 times 5 is going to be negative 20. And lastly, we'll combine like terms. X cubed does not have any like terms. But our 5x squared plus 3x squared is going to give us 8x squared. 15x minus 4x is going to be plus 11x minus 20. Yes. Mm-hmm. Yep. You're good. Questions on this here? All right. We're going to do one more of these here, and then that will be it. X plus 2 times x minus 1 times x minus 3. And again, no matter how many we have, we're just going to do these two at a time. Yeah, so we'll start off with x times x, which would give us x squared. X times negative 1 would give us negative x. 2 times x would be plus 2x. And 2 times negative 1 would be negative 2. At this point here, we can combine like terms. Our negative x plus 2x will give us positive 1x. And then we repeat the process of what we did the first time, but we're going to do it 2 more times. This time than the first, because first we have to distribute the x squared. X squared times x is going to be x cubed. X times x squared times negative 3 is negative 3x squared. Now we'll distribute our x term. X times x is going to be plus x squared. X times negative 3 is going to be negative 3x. And lastly, we'll distribute the negative 2. Negative 2 times x is negative 2x. And negative 2 times negative 3 would give us positive 6. And last but not least, we'll combine like terms. X cubed does not have any like terms. Our negative 3x squared plus x squared is going to be negative 2x squared. Negative 3x minus 2x is negative 5x. And our constant term of 6, term without a variable, doesn't have any like terms, so we just have plus 6. Questions on this here? Questions on anything we've done so far? Now there are some special product patterns. Some are difference of perfect squares. So if we have a plus b times a minus b, it's really a squared minus b squared, so we can skip to that step, or we can multiply it out. Either one gets us to the same thing. Same for square binomials or cube of binomials. We'll get more to square and cube of binomials later on, but again, it's just multiplying it by itself. And these here are just shortcuts for us to get to the answer quicker. Because if we look at this here, 4n plus 5 times 4n minus 5, it is possible for us to jump down and say that this is 16n squared minus 25 as the final answer. Or we can actually distribute through, because 4n times 4n is 16n squared. 4n times negative 5 is negative 20n. 5 times 4n is plus 20n. And 5 times negative 5 is negative 25. Negative 20n plus 20n is 0. Just telling us that our answer is 16n squared minus 25. So if we know the shortcut, we can jump right there. Or if we actually multiply it out, we get there still. One's just a little bit shorter. Because I can say the same thing for 9y squared minus 2y. Because we could jump down and say that this is 81y squared minus 36y plus 4. Because there's ways to get there using those formulas there. Or if we distribute it out, because 9y minus 2 squared is just saying we have 9y minus 2 times 9y minus 2. Well, our 9y times 9y is 81y squared. 9y times negative 2 is negative 18y. Negative 2 times 9y is negative 18y. And negative 2 times negative 2 is plus 4. At this point here, we would combine like terms, getting to this point here. And we could do a similar thing for AB plus 4 to the third and expanding it out quickly and shortly. But again, actually just multiplying them out will get us there. It just takes a little bit longer. Questions on this here? Now, one of the interesting things with this is if you multiply an expression by itself a certain number of times, it behaves like this here, and it's all following Pascal's triangle. Because the A and B values that we put, so in the middle for row 2, A squared A, no A terms, so it's just decreasing in power. A squared, A to the first, A to the 0, it's not there. B is going the opposite direction, B to the 0, B to the first, B squared. Because even in the 5th row, because again, in the number that we start off with 5 for A, 0 for B, so it's going 5, 4, 3, 2, 1, 0, or 0, 1, 2, 3, 4, 5. Third decreasing in that order. And the constant terms are given to us by the triangle itself. Now the triangle works out kind of interestingly. Because if we add the previous two together, we get the next one there. And it is always ones going out to the side. So 1 and 2 gives us 3. 2 and 1 give us 3, and then we have our ones. 1 and 3 give us 4, 3 and 3, 6. 1 and 3, 4, 1. 4 and 1 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5 is 1. Because if we did the next one, we'd have 1, 5 and 1 is 6, 5 and 10 is 15, 10 and 10 is 20, 5 and 10 is 15, 5 and 1 is 6. And then we could keep going, and that would give us the coefficients, and we could find a little bit faster way to find 2x plus 1 to the 6th, or going on from there. But that's it there. Homework. 4 through 14 even, 18, 19, 21, 25, 27, and 30.